Hey guys, recently IIT exam 2021 mathematics exam has been conducted on 14 Feb, and there are some difficult questions which are confusing many students, and many different coaching are giving different answer of these questions. So we are discussing one of those questions with some fact, concept and counter example. The question from section B MSQ of marks 2 says if there is a function from open interval a comma b to r that is differentiable also, then we have to find which of the following statements is are true. The option 1 says if f dash is strictly greater than 0 in open interval a comma b, then this implies that f is increasing in open interval a comma b. If f, option 2 says if f dash x naught is greater than 0 for some x naught belongs to open interval a comma b, then f is increasing in a neighborhood of x naught. Option 3 says if f dash x naught is greater than 0 for some x naught belongs to open interval a comma b, then there exists a delta greater than 0 such that f of x is greater than f of x naught for all x belongs to open interval x naught comma x naught plus delta. The fourth option says if f is increasing in open interval a comma b, then this implies f dash is greater than 0 in open interval a comma b. For option A, we are having a very famous result, that is if f dash x naught is greater than 0 in open interval a comma b, then f of x is strictly increasing in open interval a comma b. So option 1 is true, that is quite easy. For option 4, the option 4 says if f is increasing in open interval a comma b, then this implies f dash is greater than 0 in open interval a comma b. This is false. The reason is here. We can take a counter example. If we consider the function f of x equal to x cube on closed interval -1 to 1, then clearly we can see from the graph that x cube is increasing on -1 to 1. But since we are having f dash 0 equal to 0, so f dash x naught is not strictly greater than 0, it is greater than equal to 0. So option 4 is false. Now come to option 3. The option through here says if f dash x naught is greater than 0 for some x naught belongs to open interval a comma b, then there exists a delta greater than 0 such that f of x is greater than f of x naught for all x belongs to x naught comma x naught plus delta. For this option, first we see a definition. The definition says if f dash x naught is greater than 0, then f is increasing at x naught, and then we are having f of x is greater than f of x naught for all x belongs to open interval x naught comma x naught plus delta, and f of x is less than f of x naught for all x belongs to x naught minus delta comma x naught. So from the definition we can see clearly the in option we are having this condition, then there should be true of this condition. So from definition we can see clearly that option 3 is true. Now option 2 is so confusing. So for this option, first read the option. Option 2 says if f dash x naught is greater than 0 for some x naught belongs to open interval a comma b, then f is increasing in a neighborhood of x naught. Now for this option, first read the note. The note says if f dash x naught is greater than 0, then it does not follow the f is increasing monotonically in some neighborhood of x naught. The reason is given here because for if x1 and x2 belongs to x0 minus delta comma x0 plus delta such that x0 is less than x1 and x1 is less than x2, then it has only be proved that f of x0 is less than f of x1 and f of x0 is less than f of x2. We are having these two inequality from the definition. So we are having only these two inequality. So we can't conclude that f of x1 is less than f of x2. But for monotonically increasing, we should have if x1 is less than x2, then we should have f of x1 is less than f of x2. But we are not having this. So option 2 is false. For option 2, we can also consider the counter example, that is a piecewise function f of x equal to x by 2 plus x square sine 1 by x for x is not equal to 0 and 0 for x equal to 0. We can easily find out f dash 0. For f dash 0, we are having limit x tends to 0 f of x minus f of 0 upon x minus 0, and f of x here we have x by 2 plus x square sine 1 by x and f of 0 equal to 0 divided by x. So after simplifying this expression, we are having f dash 0 equal to limit x tends to 0 1 by 2 plus x sine 1 by x, that is 1 by 2. So f dash 0 is 1 by 2, dash is greater than 0. So f dash 0 is greater than 0. So f is increasing at 0. But in every neighborhood of 0, f dash x assumes both positive and negative values of function. Therefore, f is not monotonic in any neighborhood of 0. So we are having in this example that f of x is increasing at 0, i.e. f dash 0 is 0. But f of x is not monotonically increasing 0. So option 2 is false. So we are having here option 1 is true, option 2 is false, option 3 is true, and option 4 is false. That is 1 and 3 are correct. So thank you guys for watching my video, and comment your problem regarding this question if you have any problem, and comment also if you have any other question that you feel difficult. We can discuss that question also. Thank you.